The global plastic production compound annual growth rate from 2015 to 2022 is 2.4%. From medical devices to electronic components, various plastic products rely on plastic molding technologies for production. Depending on material properties, product design, production volume, and cost requirements, there are several different molding methods. Here are the main types of plastic molding. Injection molding. Principle: inject molten plastic into a closed metal mold cavity under high pressure. Thin the mold and take out the finished product after it cools and solidifies. Characteristics: short molding cycle, high efficiency, high degree of automation, ability to produce complex shapes, high dimensional accuracy, and good surface finish. Applications: extremely wide range of uses including household items like basins, buckets, hangers, electronic product casings, automotive parts, toys, gears, and containers. Extrusion molding. Principle: heat and melt plastic granules inside an extruder. Push the molten plastic continuously through a shaped die by the rotation of the screw to form a continuous profile. Finished products come into being after cooling, shaping, pulling, cutting. Characteristics: continuous production, high efficiency, suitable for long-sized products with constant cross-sections. Applications: pipes, rods, sheets, films, and profiles. Blow molding. Principle: a process for manufacturing hollow plastic products. There are three main types. Extrusion blow molding. Extrude a molten plastic parison and place it into a mold while still hot. Then blow compressed air into the parison to expand it against the mold cavity. The finished parts come into being after cooling and removing the mold. Injection blow molding. Make a bottomed preform by injection molding. Then transfer the hot preform to a blow mold to inflate it, and form the final product. Stretch blow molding. Make the preform by injection or extrusion. Stretch the preform axially and radially before or during the blow molding process. Under suitable material and process conditions, this method can significantly enhance the strength, transparency, and barrier properties of the product. Characteristics: specialized for producing hollow containers. Applications: various bottles and containers such as oil drums, water tanks, automotive fuel tanks. Two other important molding methods. Compression molding. Principle: place plastic into a heated mold cavity. Close the mold and apply pressure, allowing the plastic to fill the cavity and undergo chemical reactions or soften to form the shape. Remove the mold. The finished product comes into being after curing or cooling. Characteristics: relatively simple equipment, suitable for materials with poor flow or requiring chemical cross-linking, and low internal stress in the finished product. Applications: switches, sockets, melamine tableware, and large flat or shallow cavity products. Thermoforming. Principle: thermoplastic sheets or plates are heated to their softening temperature and then shaped onto a single mold using vacuum suction, air pressure, or mechanical pressure. Product is cooled and set. Characteristics: lower equipment investment and mold costs. Commonly uses aluminum, wooden, or resin molds. Suitable for large-sized, thin-walled products with large surface areas. Raw material costs vary depending on the material type, and the process requires pre-formed sheets. There may be some waste material generated during production. Applications: disposable cups, bowls, trays, food packaging, automotive interior parts, signs, and display racks. 3 future trends in plastic molding. 3D printing. As an emerging key direction in plastic manufacturing, the application scenarios for 3D printing are increasing. Principle: 3D printing builds three-dimensional solid models by layering materials such as plastic filaments, powders, or liquid resins. There are various technologies including fused deposition modeling (FDM), stereolithography apparatus (SLA), selective laser sintering (SLS). Characteristics: no mold required, capable of producing extremely complex geometries, suitable for small batch, customized, and prototype manufacturing. However, it is slower, relatively more expensive, and the strength and surface quality are generally not as good as traditional molding methods. Applications: product prototypes, mold prototypes, small batch custom parts, complex structural components, and medical models. 4. Choosing the right plastic molding process. Selecting a plastic molding process requires a comprehensive consideration of multiple factors, including the characteristics of the plastic material, product design details, and performance requirements to determine the optimal method. We have introduced 6 plastic molding processes in this video, each with its own advantages and disadvantages. If you are unsure which one is best for your project, please feel free to contact Zintilon. We have a team of professional engineers ready to support you. If you find this video helpful, don't forget to like and subscribe to our